Hello everyone, my name is Johnn Brachuz A. Manda. So in this presentation, we're going to tackle all about debugging and troubleshooting APIs as well as securing APIs. So by now, we already know that APIs are mechanisms that enable two software components to communicate with each other using a set of definitions and protocols. So, for example, the Weather Bureau software system contains daily weather data. So, the weather app phone talks to this system via APIs. So, it will show you daily weather reports on your phone. So, that is API. So, in this presentation, we will going to divide it to 6 groups or general ideas. So, firstly, its introduction. Next is debugging and troubleshooting strategies and also its techniques. Next, we're going to tackle all about API issues, tips for it, and also the best practices for API security. So, moving on. Let's start with introduction to debugging and troubleshooting APIs. So what is API debugging and troubleshooting? So API debugging and troubleshooting is the process of identifying and resolving issues or errors in an application programming interface or API. So again, an API is a set of protocols, routines, and tools for building software applications. So it enables us the communication between different software components. So allowing to exchange data and execute functions. So I will say this again. So when an API is not functioning correctly, so developers need to troubleshoot and debug the code to identify the root cause of the problem. So that is all about debugging and troubleshooting. So next. So let us differentiate between debugging and troubleshooting. So to debug something, it involves finding and fixing bugs, hence the word debug. So bugs or errors in the code, while troubleshooting involves identifying and diagnosing problems that may caused by issues outside of the code itself. So in short, troubleshooting uncovers the deeper root cause of an issue. And debugging are the steps to fix that thing that broke. So I hope we all understand the difference between debug and troubleshoot. So let us move on. So, why it is important to have a good debugging and troubleshooting process in place. So, having a good debugging and troubleshooting process for APS is essential for several reasons. So, I have listed 5 things why it is important. So, first one, to improve software quality. So debugging and troubleshooting help identify and resolving issues in the code. So it improves the overall quality of the software. So that is the general idea. So this leads to a better user experience, of course, and it reduces the risk of customer dissatisfaction or loss of business if you want to have a company in the future. So by using an API, you should have an improved software quality through debugging and troubleshooting. Next is faster issue resolution. So a well-defined debugging and troubleshooting process helps developers quickly identify and resolve issues, of course. So what does this mean? So this means that customers experience less downtime or disruptions to their work. So which can lead to increased productivity and efficiency. So I am talking all about customers experience because the general idea of debugging and troubleshooting an API usually involves in a company or other places that works in a group or a team. So that is for faster issue resolution. Next, third one. So cost savings. So effective debugging and troubleshooting can help reduce the cost of fixing issues in the software. So what I said, faster issue resolution. So this can save you a lot of money. So by catching these issues early, before they became major problems, so us developers can save time and resources that might be required to fix more issues later on, rather than it will cause, again, major problems. So cost savings. Second to the last is to enhance security. So in this presentation, we will going to talk also about securing APIs. So we'll tackle on that later on. So the importance of debugging and troubleshooting is to enhance security. So it also help identify potential security vulnerabilities or exploits like XSS or injection attacks. So we'll talk all about that later on. So addressing these issues early can help prevent data breaches or other security incidents that could be costly and damaging to a company's reputation. So lastly is for continuous improvement, of course. So a well-designed debugging and troubleshooting process allows developers to continuously improve the software by identifying and addressing issues as they arise. So this helps ensure that the software remains stable and reliable over time, even as of new features are added or existing ones are modified. So this is an important view of importance with the debugging and troubleshooting of APIs. So we are involved with other apps and games. So we also continuously see them as always updating by the time it will be announced, or later on for the past few years it will going to grow as an app or as a game, or in this case an API. So overall, a good debugging and troubleshooting process is a critical for the success of an API. So it helps ensure that the software is of high quality, operates smoothly, and therefore, of course, it is secure and reliable. So providing a positive experience for both customers and also us developers. So that is the idea and the importance of debugging and troubleshooting. So let us proceed. So the common challenges associated with debugging and troubleshooting APIs. So debugging and troubleshooting APIs can be, of course, be challenging, as many potential issues can arise. So in this presentation, let us also talk about the common challenges that developers may face. So first one is complexity. So as I said earlier, troubleshooting and the debugging APIs can be challenging. So by challenging, we're talking all about complexity, because APIs can be complex because it involves multiple components and layers of code. So this can make it difficult to identify the source of a problem and track down the root cause. Next is lack of documentation. This is also a common challenge that a developer might face, because poor or incomplete documentation can make it difficult to understand how the API is supposed to work. So this can make debugging and troubleshooting a bit more challenging. So later on, we will going to talk about monitoring and logging, which is a type of documentation for API. So we will talk also about that later on. So next is integration issues, because APIs may be integrated with other software components, because that is what API is all about. So this can make it difficult to determine where an issue is occurring. So in some cases, the issues may be related to the integration rather than the API itself. Next is environment differences, because developers may encounter issues that only occur in certain environments, such as when an API is deployed to a specific server or accessed using a particular browser. So for example, a software or a browser, so the environment may differ. So this can make it challenging to replicate the problem and identify the root cause. So next is time constraints. So debugging and troubleshooting can be time consuming, of course, because particularly when dealing with complex issues, a developer may face pressure to resolve issues quickly, especially in companies which your boss tells you to resolve these issues quickly. So it can be time pressure. So it can make it challenging to thoroughly investigate and identify the root cause. So lastly is inconsistent or incomplete error messages. So um, sometimes like in games or apps, so some of the error messages are also vague. So in these challenges, so inconsistent or incomplete error messages, because error messages may be difficult to understand what the problem is and where it is occurring. So this is one of the challenges, probably be the most common actually. So to overcome these challenges, so developers can take steps such as thoroughly documenting the API, testing it in a variety of environments, uh, like I said earlier, using logging and monitoring tools to track errors, which I'll be tackling later on, and working collaboratively to share information and knowledge about the API. Because when working on API, it is not just only you or one man. So it is a team project. It's collaborative. Now, finally, let's talk about the strategies for debugging APIs. So as I said earlier, let's talk all about logging. So logging in an API refers to the process of recording events, transactions, errors, and other information related to API's operation. So this data is typically stored in log files. So some of the file extensions can be .log, or sometimes different file extensions can be just text files. So from the word logging, so like we go to libraries or offices, so like we jot down our names and signatures, time and date when entering a facility. So that is also the same logic here in APIs. So logging APIs, so which can be used for debugging, troubleshooting, auditing, and analysis purposes. So logging in an API is important for several reasons. First one, let's talk. So this is an example of an UI of a logging tool. So later on, I will recommend or give examples to logging tools. So this is the UI. So like we have logs here. As we can see, the message prompt, the event type, the metadatas like the time, here, date and time, and the group, what group, and also what server it is going. So like filters here, max result. So that is the general idea of what an logging API is. Here also another UI. Here this is an example of a CSV API, so an API log. So as you can see here, like timestamp commands, execution time, its weight or the file size, what is being processed by, and whom. This is the code. So logging an API is important for several reasons. So first one is for, of course, debugging and troubleshooting. So when an API encounters an error, logging can provide developers with valuable information about what went wrong, where the error occurred, and what was the data involved. So this information can be used to diagnose and resolve issues more quickly and effectively. Next is performance monitoring. So logging can also be used to monitor performances of an API. So this includes responses time, server load, and other metrics. You can also the metadata of it. So this information can help developers identify areas for optimization and improve the overall performance of the API. So next is security auditing. So by logging requests and responses, APIs can track access to sensitive data and monitor for potential security breaches. So this can help developers identify and respond to security incidents more quickly because you have already audit through logging. So this protects the API and its users from harm. Next, and the last one is compliance and regulatory requirements. Some industries or companies and regions have specific compliance or regulatory requirements for logging data. So APIs that handle sensitive data, financial transactions, or personal information may be required to log certain events to comply with these regulations because we're going to follow here the law for the internet. So we're going to comply and meet the regulatory requirements for security and especially for privacy. That is the main thing here. So overall, logging is an essential tool for API developers, helping them monitor and maintain the performance, security, and compliance of their API. So by logging data in a consistent and structured way, developers can gain valuable insights into the operation of their APIs and make informed decisions about how to optimize and improve them. So logging, remember that logging is an essential part for any API development process. So next is the best practices for logging. So as I said earlier, logging is an essential part of any API development process as it helps developers track and understand what's happening within the system. So here are some best practices for logging in to API. First one, Use a consistent logging framework. What does this mean? So using a consistent logging framework across all components of the API, it helps to ensure that logs are standardized. So I hope you already know all about standardizing. So this make it easier to search and analyze. So next is to log meaningful events, of course. So log only meaningful events such as error messages, system warnings, or significant user actions to reduce the amount of noise in the log files, because this can be uh, clut, uh, more confusing to the eyes. So avoid logging sensitive data also, like passwords or credit card numbers. So because as you know, hackers can well define what log means. So yeah, they have knowledge of it, so they can search through logs. If you're not careful with the privacy of the users, you can leak the passwords and or credit card numbers of the users. So that is a red flag, my friend. So next is to use a structured logging. So using structured logging to help organize and filter log data. So structured logging makes it easier to search, filter, and analyze logs, even if the logs are spread across multiple systems. Next is to use log levels appropriately. So use log levels. So it for example, debug, info, warning, error, and critical. So those are some log levels. So use log levels appropriately to prioritize and filter logs. So as I said earlier, you should prioritize the debug info, the general info, warning, error, and critical. So for example, use debug logs during development and testing to identify potential issues. But take note, avoid using them in production. So only for logging. Next is include context information. So include text information in logs such as user ID for database management, session ID, and request ID. So you should normalize these three IDs to help track user actions and troubleshoot issues. Next is log timestamps. This is very crucial because log timestamps for each event include the date and time in a standardized format. So because it helps correlate events across multiple systems. Next is to monitor logs. So later on, we'll also be talking about monitoring. So this is a different strategy as well. So monitoring logs regularly to identify trends, detect issues early, and respond quickly to problems. So set up alerts for critical events and errors that require immediate attention. So lastly, ah, this is an example of how to monitor logs. So this is an Amazon logging tool. So as we can see here, the general idea of how to monitor logs, like this one's the I think these are the IDs or the codes. This is the timestamp in UTC plus zeros. So that is a general UI for monitoring logs. So to add also, we can also we should also store logs securely, because store logs such as central logging system or cloud service, and protect them from unauthorized access. So by following these practices, API developers can create comprehensive and useful logs that can help improve the reliability and performance of their application. So, let us give you some examples of logging tools, shall we? So there are many logging tools available for API, and the choice of tool depends on the various factors such as development language, hostile platform, and budget. So here are some examples for logging tools for API. So in a company or in an industry, so usually a type of logging tools that helps with their budget, because it's a company. So first example of a logging tool is called Logly. So for insights, Logly is a cloud-based logging tool. It means you can run this in a browser that supports various programming languages and platforms. So it provides real-time logging, advanced search, and alert capabilities. So that is Logly. Next is Elasticsearch. So Elasticsearch is an open source distributed search and analytics engine. So that can be used for logging. So it supports indexing and searching logs in real time, and provides advanced analytics and visualization features. Next is Papertrail. So again, Papertrail is also a cloud-based logging tools that supports various platforms and languages. So it provides real-time logging as well, search, filtering capabilities, and integrates with popular tools like Slack and PagerDuty. Next is Graylog. So Graylog is another open source logging tool similar with Elasticsearch that supports various platforms and languages. So it provides centralized logging, search, and alerting capabilities that supports uh, custom dashboards and plugins. So Graylog can be customized as well. Its I mean. Next is Splunk. So Splunk is a popular enterprise grade logging tool. This is also used for companies because it supports various platforms and languages. So it provides real-time logging again. So search and analysis capabilities, and supports machine learning, and get this, AI powered insights. So this is what is best for Splunk because it has AI powered insights. So I drank up some water. So next, lastly for our examples is Fluent. So Fluent is another open source logging tool, so that supports various platforms and languages. So it provides unified logging and data collection, and supports real-time streaming, filtering, and parsing. So um, these are just few examples of logging tools for API. So you can have both or three of these. So you can search for other logging tools because there are many other options available. What is important is to choose a tool that fits the specific needs and requirements of the API. So also for the development team. So what I mean by team is it can also apply to companies and industries as well. Let us move on about monitoring. So I mentioned this earlier. So monitoring is the process of observing and measuring the performance, availability, and reliability of an API in real time or near real time, because you can really process real time. It depends on what system you are using. So mainly it involves tracking various metrics like metadata and other timestamps like that. So it's similar to logging, but with logging, uh, you have files that will support what is being monitored. So in monitoring, it is crucially real time. It is real time monitoring. So API logging, it can be involved with post monitoring, like it is in a different file, you can search with it. So uh, it involves such as response time. So monitoring also shows error rates, system utilization to identify issues and ensure that the API is functioning correctly. So this is an example of a monitoring tool of its UI. Like we can see here the web throughput, uh, the web response, like all in all. Like you will be monitoring all what is doing in the API. Like here, the web performance, you have a graph here. So another graph here in a different style, web uptime. So this is an example of an endpoint dashboard. This is a endpoint dashboard. Also an example. So it's a little bit blurry. So but you can see the general idea. It is mainly dashboard monitoring. So monitoring uh, is important in API for several reasons. I'm getting. First one is to ensure availability and uptime, because monitoring helps uh, to ensure that the API is available and accessible to users at all times. Because by tracking metrics such as server uptime and response time, the API developers can quickly identify and address issues that may impact availability. Next is improving performance. Why? Because monitoring can help identify performance issues and bottlenecks, so such as slow response times or high CPU usage. So through debugging and troubleshooting, because of monitoring, you can see what are the causes of slow responses time or high CPU usage, because this allows developers to optimize the API and improve its performance. Next is for preventing errors. So monitoring can help identify and prevent errors before they impact users, because by tracking error rates and other metrics, developers can quickly identify and resolve issues. So it reduces the risk of downtime and negative user experience. So because users experience is uh, a well insight for a good performing API. So next is scaling the API. So monitoring can help identify when an API is reaching its capacity limits. So when indicating when it is time to scale the API infrastructure to handle additional traffic and users. So such as high usage rate or the web speed. So lastly is to meet the service level agreements or SLAs. So monitoring can ensure that the API is meeting its SLA with users. So by tracking metrics such as response time and availability, get this, developers can help ensure that the API is meeting the agreed upon levels of service, because that is all about SLA, service level agreements. So these are the agreements between you as a developer and for the users. And those are your agreements. So in summary, monitoring is essentially an API development to ensure availability, improve performance, prevent errors, scale the API, and meet service level agreements. So by monitoring the API's metrics, developers can quickly identify issues and take corrective action. So it also ensures that the API remains reliable and performs optimally. So what are the best practices for monitoring API? So here are some practices, the best practices. So first one is to define clear monitoring objectives. What it means is, before we monitor an API, it is also important to define clear objectives and metrics that align with the business goals, especially in a company or in a team collaboration, because this will ensure that monitoring efforts are focused on the most important metrics and provide actionable insights. Like logging, it should not be in a cluttered way. So insight the most important metrics. Next, monitor from the user's perspective. What will be the user what will be the user's experience will be. So monitoring should be done from the user's perspective to ensure that the API is meeting with their expectations, not in a development phase from the API or the monitoring, but as a user. So you have to put yourself in their shoes, if that's correct. So because this includes monitoring response time, error rates, and other metrics that impact the user experience. Next, monitor at different levels. So monitoring should be done at different levels, including infrastructure, its environment, application, and business levels, because this will help identify issues that may be impacting the API at different levels and enable faster troubleshooting and resolution. Next is the use of a combination of monitoring tools. So as what I said earlier, you can use 2 to 3 or how many tools you'll need for monitoring, because if you use a combination for monitoring tools such as APM tools, log monitoring tools, as what I said earlier, and monitoring tools to gain a comprehensive view of the API's performance and identify issues quickly, because monitoring tools should not be jack of all trades. You should have at least masters of one. If you've understand that logic there. So use a combination of monitoring tools, because every tools has a different objectives when monitoring APIs. So use a combination of them, like for APM, logging, and network monitoring. An example for network monitoring, you can use, there are some, I don't know, but there are some for network built in a computer. So some are web based, you can use that, but some are tad bit inaccurate. So use a combination of monitoring tools. That's the idea. So next is establish baselines and thresholds. So establish baselines and thresholds for key performance metrics such as response time and error rates. So this will help identify anomalies and deviations from normal behavior, enabling faster identification of issues. Next is implement proactive alerts and notifications. So it is important to implement proactive alerts and notifications for critical events and issues. So this can be turned to error prompts, or what will be the notification style will be, because this will enable for faster responses and minimize the impact of issues on users. Next is to analyze and act on monitoring data. So monitoring data should be analyzed regularly to identify trends and patterns that may indicate underlying issues. So actions should be taken promptly to address issues such as scaling the infrastructure, optimizing code, or addressing performance bottlenecks. So by following these practices, API developers can ensure that the API is performing optimally. So meeting user expectations and delivering the desired business outcomes. Same with logging tools. I will also give you some examples of monitoring tools, but beware, there are many monitoring tools available for API monitoring, and the choice of tool depends on various factors such as development language, the hosting platform, and budget. So the first one is Datadog. So Datadog is a cloud-based monitoring. Again, it can be run through a browser. So it provides real-time monitoring and alerting for APIs for notification and applications and infrastructure. So it supports various platforms and languages and provides dashboards and visualizations to monitor API performance. Another one is New Relic. So New Relic another cloud-based monitoring tool that supports various platforms and languages. So it provides another real-time monitoring, alerting, analysis for APIs, and all that stuff that is the same with Datadog. So you can experiment with these both. App Dynamics. So this is different because this is an APM tool. So what does an APM means? So APM means application performance monitoring. So this is mainly focused on applications. It also supports various platforms and languages. So it provides real-time monitoring, alerting, and all that stuff with the same for other. Also, it supports deep code level visibility and diagnostics. What is different with App Dynamics, because it is an APM tool, unlike Datadog and New Relic that are cloud-based monitoring. So Prometheus is an open source monitoring tool that supports another various platforms. So these are the same. You can experiment with this one. So what is different by this, because it also supports custom dashboards. So you can customize what the UI will be looking, the aesthetics, and it also have the opportunity uh, to customize alerting rules. And lastly, for our example is pingdom. So from the word itself, ping, it is a network uh, monitoring tool. So another, you can run this in a browser because it is a cloud-based monitoring tool. So it also provides advanced reporting and analysis features, but this one is mainly for network monitoring. We have another one called Nagios. So Nagios is another open source monitoring tools. So these are the same with Prometheus. It's the same vibes with it, if my logic is correct. So it also uh, supports custom dashboards and alerting rules. But take note, these are just few examples of monitoring tools for API. So there are many other options available. You can search it on the internet. But it is important to choose a tool that fits the specific needs and requirements of the API and the development team. So I cannot stress this enough because there are many types you have to monitor with. So networking, uh, the performance, the APM. So there are various types to look for. So you can use the combination of these. Next, for practices for uh, API is to use debugging tools. So this is the main point here, because debugging tools for API are software tools that help developers identify, analyze, and fix issues in their APIs. So these tools can be used to diagnose issues such as incorrect or unexpected behavior, like message prompts. So performance bottlenecks, security vulnerabilities, and other problems they may impacting the API's functionality. So debugging tools for API are essential for these several reasons. Ah, let us first look at what an debugging tool looks like. So this is a example of a dev HTTP client. So a debugging tool. So this is what it looks like for this type of debugging tool. So debugging tools are important for API development for several reasons. First, faster issues identification and resolution. So I've said this earlier, faster resolution, because debugging tools can help developers quickly identify and isolate issues in the API. So reducing the time and effort required to troubleshoot and fix problems. Next is to improve code quality, because debugging tools can help developers to identify potential issues and improve the quality of their code. So by detecting and fixing issues earlier in the development process, developers can prevent more significant issues from arising later on. Next is to enhance collaboration, because some debugging tools can facilitate collaboration, like two developers at once, like mouses are all everywhere, because you can collaborate with your team or among developers by providing a common platform for the identification and resolution. So same with, I think, with uh, spreadsheet, no, Google Sheets, like you can collaborate. So as well as debugging tools, you can also collaborate. So this can help teams work more efficiently and effectively together. Lastly is to improve customer experience. So through debugging in general can help developers identify and fix issues before they impact the customers. So improving the overall customer experience with the API. So in summary, debugging tools are essential for API development to ensure that APIs are functioning correctly, identify and isolate issues quickly, improve code quality, and enhance all the overall customer experience. So let's talk about the best practices for using debugging tools because this is the main point for this presentation here. So here are some best practices for using debugging tools when developing and troubleshooting APIs. First, understand the debugging tool. Before using a debugging tool, before you use it, make sure you understand how it works. Like what kind of debugging tool is this? So understand what it offers or what features it offers because this will help you use tool more effectively and efficiently because if you don't know what are the most useful features, it can you will have a more slow process of debugging a code or the API. Next is to use the tool throughout the development process. Of course, I can stress this enough because it can be used throughout the development process, not just when the issues arise. Take note of that. So, not just in the development process, but also, not just when the issues arise, but also in the development process. So, use the tool during development can help you identify potential issues early and improve the quality of your code. Not just, take note, when the issue arises. Use the tool to reproduce issues. So when troubleshooting issues in your API, use the debugging tool to reproduce the issue and capture relevant data so you can know what is going on with your code in your API. So reproduce the issue so for that you can learn how the issue works or how this issue occur. So because this it helps you identify the root cause of the issue and that is the way to develop a solution. Next is to analyze the captured data. So through monitoring, logging, now you are debugging, you can capture data related to an issue. So take the time to analyze the data and identify patterns or anomalies. So this can help you identify the root cause of the issues more quickly. So since we have internet now and this new cloud-based tool, ChatGPT, we can use these tools as an instrument to help us analyze more about the captured data because we all know that some issues are common amongst developers. So we can see some in the internet for insights. Next is since API can be is developed commonly through collaboration, so collaborate with other team members. So have teamwork. So debugging tools can be a powerful collaboration tool. So share the capture data with other teams to help troubleshoot issues and develop solutions. So brainstorming, my friend. So keep track of issues. So when using debugging tool to troubleshoot issues, keep track of the issues you encounter, like how they were resolved or any related documentation. Uh, as I said earlier, through logging, this can help you identify common issues and develop strategies for preventing them in the future. Lastly is to keep the debugging tool updated, as well as your system, your computer system. It is important to for Windows to update uh, your OS. So it also updates you for security and to fix other issues within the system. So same with APIs. So keep the debugging tool updated. So it for cloud-based tools. So this is not necessary because it is automatic. But when we use open source tools in a software, so keep the debugging tool updated, because they are constantly evolving. That is the main point. Like with new features and bug fixes being released regularly. Because funny as it sounds, ironically, some debugging tools have bugs in them. So new features and bugs fixes being released regularly. So make sure that you keep the tool updated to take the advantage of these improvements, as we say, and ensure that the tool is working as expected. So by following these best practices, developers can use debugging tools effectively and efficiently through to troubleshoot issues and improve the quality of their code and enhance the overall performance of their APIs. So here are some debugging tools. So let's proceed with the first one, called Postman. So Postman, this is a popular API development tool. Not just for issues, it is an development tool. This includes a range of debugging features, including the ability to view and analyze API requests and responses, track performance metrics, and especially, and of course, to debug code. Next is Fiddler. So Fiddler, another debugging tool that enables developers to inspect a debug web traffic. So this is used to mainly this is mainly for inspecting and debugging web traffic. So it includes features such as the ability to capture and analyze HTTP traffic, the hypertext. So it also inspect responses and debug code, of course. Next is Insomnia, like my sleeping schedule. So this is an open source API development tool. So this includes range of same with other ones, like it includes the ability to view and analyze API requests and response, track performance metrics, and so on, so on, and to debug the code. Next is Charles. So Charles is a debugging tool that enables developers to inspect and debug web traffic. So this is same with Fiddler. So yeah, basically it has the same features with Fiddler. Next is Swagger UI. So another open source tool that enables us developers to visualize and interact with APIs. So you can switch here as a user. So because it involves with requests and responses, it can also view documentations and also to test the API endpoints. Next is a popular one, is a cloud-based debugging tool. So we can see this when we open Chrome and right click anywhere, and you can see the inspect button. So from there you can access the development tools of the Chrome. So you can see there the set of debugging tools built into the Google Chrome browser. So uh, yeah, you have the ability to inspect and edit HTML, the CSS, and JavaScript, because Chrome is ran through JavaScript, HTML, and CSS. It also shows the monitor network activity and also, especially, to debug code. Next one is a popular one. I'm sure you already heard about this. Visual Studio Code, because some of our development tools are being made here in Visual Studio. So mainly Visual Code Studio is a code editor because it includes range of debugging features for API development. This includes features, the ability to set breakpoints, to step through code and inspect variables. So these are just few examples of many debugging tools available. So the choice will depend on you and your specific needs and preferences. Moving on, finally, the techniques for troubleshooting APIs. So as we troubleshoot an API, as I said earlier, it can be a complex and a time-consuming process. However, so there are several techniques and best practices that can make it easier to identify and resolve issues. So here are some most effective techniques for troubleshooting APIs. So first one is identifying and isolating problems. So what does this means? So when we identify and isolate problems in APIs, uh, it requires a systematic approach. So here are the steps. So some of these I mentioned earlier, like this one, to reproduce problem or reproduce the problem. So the first step in identifying and isolating an API problem is to produce the problem itself. So this involves trying to replicate the issue by sending the same request to the API that caused the problem. So if you if you can recreate the problem, you can also fix it. That's the logic here. So uh, make sure also to use the same parameters, headers, and payload data as the original request to your original API that you have developed. Next is check the API response. So once you have reproduced the problem, check the API response for any errors or messages. This can often provide clues about the cause of the issues. Uh, for the check API response, so there are some, I know you've encountered this, some HTTP status code, if you can notice this, like error 404. Have you heard of that? Error 500 or error 503. You can search this in the internet. What are the descriptions at the titles of it? Like 404 means not found or not found in the internet, or the content is not anywhere to be found in the protocol. So every status codes has its fixations. So you can indicate these issues with connectivity, server errors, and authentication issues. So you can search this in the internet. Uh, these are called HTTP status codes. So you can Google it. Uh, Type HTTP status codes. Like there, you can see all the lists, like 404, 500, or 503. Like 404, server errors, uh, authentication issues. Next one. As I said earlier, we should have different environment uh, process of API. So this one, use a web-based client, means the browser. So a client like Postman or Insomnia tools uh, can be an invaluable tool for identifying and isolating API problems, because mainly we can use API in a web-based environment. So we should also use a web-based client. So these tools allow you to test API endpoints, examine the response headers and body, and view any errors or warning in a view-based viewpoint. You can also use them to create and send custom requests with different parameters, headers, and authentication uh, tokens. Next is check the API logs. I can stress this enough because I've already talked about logging. So most API platforms will log all incoming and outgoing requests. So as well as any errors or exceptions that occur. So by reviewing logs can help you identify the specific request that is causing the issue. So as well as any errors or exceptions that are being generated. So you can also use log analysis tools like I've said earlier, Elasticsearch or Splunk, to search and filter the logs for specific wordings or patterns. Next is to test with different inputs. So later on, I will also discuss with input issues. So test with different inputs. So testing the API with different inputs can help you isolate the issue and determine whether it is related to the input data or maybe the API itself. So I want you to try sending requests with different parameters, headers, and payloads to see how the API responds. So send some various types. So you can also use tools like JMeter or Gatling to simulate high volume traffic and see how the API performs under load. So JMeter and Gatling are some of the what we call test tools for stress or high volume traffic. These are stress tools. Like you can see in some YouTubers to stress the performance of the system. So it can so you can audit how much it handles with the software or other stuff that are going. So next is to collaborate with the API provider. So you as yourself a provider, if you're still having trouble identifying and isolating the API problem, you should collaborate with the API provider. So they may have additional insights or tools that can help you identify and resolve the issue. In short, ask an expert. So be sure to provide as much detail as possible. So include the specific request, the response data, any error messages or codes, and any relevant logs or debug output. So, by following these steps, you can systematically identify and isolate problems in an API towards a resolution, a clear resolution. Next strategy for troubleshooting is to analyze the data. I've already said earlier how important to analyze the data. So, uh, it is an essential part, of course, of understanding how an API works because identifying any issues or errors can optimize its performance. So, the first step to analyze data is to understand the data format. So, APIs can return data in different formats like JSON, JSON, can also be an XML file or CSV or other binary formats like protobuf, protobuf and avro. So understand this data format. So you can just study one by one. JSON, XML, CSV or binary formats like protobuf or avro. So it's essential to understand the data format to be able to interpret and analyze the data. So use tools like Postman, Insomnia, or curl to inspect the response body and headers. So next is to use data visualization tools. So data visualization tools like Table AU, how do you say this? W, or Power BI or Google Data Studio. These are visualization tools. These are useful for visualizing the data returned by an API. So they can show you the graph of the data. So graphs, charts, or dashboards so that we can summarize the data. So it helps us see more clearly what is going on with our API. It also helps you identify the trends, patterns, or anomalies. So these tools also allow you to slice and dice the data based on different parameters or dimensions, not just in one cluttered form. I don't know. So next is to filter and aggregate data. So APIs can return large amounts of data, so making it challenging to analyze. So use filtering and aggregation techniques to extract the data that is relevant to your analysis tools. So we can also use to filter an aggregator like JQ, SED, or grep to filter the data or to manipulate JSON or CSV data. Next is monitoring API performance or monitor API performance because this can help you identify any performance issues or bottlenecks. So use tools like New Relic, Datadog, and Prometheus to monitor API response times, also error rates, and throughput. So these tools allow you to set up alerts when specific thresholds are breached. Next is correlate with API data with other data sources. What it means that APIs often interact with other system or data sources. So through correlating API data with other data sources can help you gain insights into the broader context of the data. So there are some tools to correlate API data with other data resources such as Apache Kafka, if you have heard of that. So also AWS Kinesis, or a more popular one is Google Pub or Sub, so that we can stream data from different sources and analyze them in real time. Lastly is to collaborate with data scientists or analysts. So as computer engineers, so not most of the types of data we can handle. So we can consult with data scientists or analysts. So if you're really struggling to analyze the API data, so contact them or collaborate with them, because they can provide you insights into the data and help you create predictive models or machine learning algorithms to analyze the data. So you should not stress yourself enough as a computer engineer in the future. Remember, so through collaboration with data scientists, because they've mastered that field of the technology. So collaborate with them. There's no harm in doing it. So by using these techniques, remember, you can effectively analyze data in APIs and gain valuable insights into how they are performing, to identify issues and optimize their performance. Next technique is testing and monitoring. So this is a critical technique for ensuring that they're functioning correctly. So meeting performance expectations and providing a positive user experience. So here are some techniques for testing monitoring APIs. So these are types of testing and monitorings. Yes. So first one is called functional testing. So what does this means? So this involves verifying that the API functions correctly according to the API specification. So you can use again like Postman, SOAP UI, or Insomnia to test the API's endpoints. Also, it can help you to verify the response and validate the API's schema. So functional testing ensures that the API meets the requirements and works as expected, of course. Next one is called load testing. So this involves stimulating high volume traffic to the API to test its performance and scalability. So this I mentioned again, so use JMeter, Gatling, or another one is called Locust to generate realistic traffic and test API's response times, throughput, and resource utilization, because you can't ask many users. So you don't need to ask real users, like real human users, to simulate the load testing or the high input testing. So you can use like uh, tools like JMeter, Gatling, or Locus to generate realistic traffic, uh, like high volume traffic, because that is difficult for real humans to replicate with, I don't know, with thousands of users. So load testing can help identify performance bottlenecks. Uh, it ensures that the API can handle a high volume traffic. Next one is called security testing. So ah, what does security testing involves? So this involves identifying and mitigating potential security vulnerabilities in the API. So for security testing, you can use tools like OWASP, spelled OWASP, OWASP Zap. You can also use burp suit or Nessus to test the API security by identifying and exploiting vulnerabilities like injection attacks or like we called XSS or cross-site scripting. We'll tackle we will be tackling that later on. So or broken authentication in general. So security testing ensures that the API is secure and doesn't expose sensitive data or functionality. Next one type of testing is contract testing. So contract testing involves testing the API's contract or interface with the other APIs or microservices. So you can use tools for contract testing like Pact, Spring Cloud Contract, or Pact2 to test the API's compatibility with other services by defining the contract that specifies the API's inputs, outputs, or behavior. So contract testing ensures that the API integrates smoothly with other services and doesn't break any contracts. Next one is API monitoring. So API monitoring involves tracking the API's performance. So that is the general of API monitoring. So to track the API's performance and availability in real time. So again, you can use the monitoring tools like Pingdom, Uptime Robot, or New Relic to monitor the API's response times. So also its uptime and error rates. So this alerts you to any performance or availability issues. So this allows you to take corrective action quickly. Lastly is error logging and analytics. So we've tackled logging, so now specifically error logging and analytics because this involves capturing and analyzing errors that occur in the API. So you can use logging tools like Splunk, ELKey, Stack, or Graylog to capture the analyzed API logs and identify the root cause of any errors or exceptions. So error logging and analytics can help you quickly identify and fix any issues that occur in the API. So by using these techniques, yes, you can effectively test and monitor APIs, so ensuring they're functioning correctly, meeting performance expectations, and providing a positive user experience because that is all about APIs. So next one, I think for the final section or of our agenda in our presentation is to discuss the common API issues and how to fix them. So maybe you will be encounter this in the near future when developing APIs. So let us talk about what are the common issues. And take note, you can also search your problems in the internet having similar results. So you can also use how they fix that problems. So the first common API issue is called authentication and authorization issues. So authentication and authorization are important security measures that are used in API to ensure that only authorized users or you as a developer or system are allowed to access the protected resources like those sensitive datas. But first, let us talk about the differences between authentication and authorization issues. So Authentication is the process of verifying the identity of a user or system that is requesting access to an API. To add this one, so this is typically done by requiring the user or system to provide some form of credentials. So these credentials can involve like username, password, a token, or a certificate. So authentication uses the API. Issues in API can arise if the authentication mechanism is not properly implemented. So if the credentials are not securely transmitted, or if the authentication data is not properly stored and managed. So that is authentication to ensure its authenticity. Yes, authenticity. So next is authorization. So what is authorization? So authorization, in the other hand, this is the process of determining whether a user or system is allowed to access a specific resource or perform a specific action. So authorization issues in API can arise if the authorization mechanism is not properly implemented, like some leakage of the information or the data, especially the sensitive ones. So if the access control rules are not properly defined, or if the authored data is not properly stored and managed, so there may be authorization issues like leakage of sensitive data. So it can be easily be hacked. So um, authentication and authorization are critical security aspect of any API. This is the most important one because they ensure that only authorized and authenticated users or system can access the API and its resources. So through that, here are some common authentication and authorization issues in APIs and how to fix them. First one is weak passwords, of course, because weird weak passwords may violate the authenticity and the authorization of the API. So weak passwords are the most common cause for authentication failures because they can be easily guessed or cracked by attackers, especially hackers. To fix this issue, so this is a user issue mainly. So it should require the users to create a strong password that are difficult to guess. So you as a developer, you should not take weak passwords. So you can identify like most of the password systems of other APIs. They suggest what is a strong or a weak or an average password. So you should not receive weak passwords. So you should tweak that on your code when making the API. Also, implement multi-factor authentication just to add an extra layer of security. Next is insecure communication. Not secure communication can lead to authorization issues. So, as an API developer, so APIs that can communicate over unsecured channels such as HTTP are vulnerable to man-in-the-middle attacks. What this means, you should fix this issue uh, to secure use secure communication protocols like HTTPS, not because this is the most secure protocol to use. So uh, to fix insecure communication issues, use protocols like HTTPS. So broken authentication and session management issue. So APIs that use session IDs or tokens for authentication can be vulnerable to attacks if these credentials are not managed securely. So you should normalize these ones. To fix this issue, implement a strong session management and revoke tokens when necessary. So that is the fix in here. So uh, you should implement strong session management and revoke tokens. So next one is insufficient authorization checks. So APIs that lack proper authorization checks can allow unauthorized users to access resources. So how do we fix this? So you should implement appropriate authorization checks such as role-based access control or RBAC. Role-based access control, you can search that. So this means this can help to ensure that only authorized users can access resources. So this can filter out that are not authorized users. So that's it. This one is this is a more common one is injection attacks. So for injection attacks, this is mainly for database for our APIs, the back end. So mainly APIs that use SQL or other types of injection vulnerable languages can be exploited by attackers to execute arbitrary code. So like example for the Windows operating system, they have a option in the Microsoft Windows security called memory integration, or I think what is called core isolation. So this prevents the core memory of your OS to be protect against unwanted scripts or injections of code. So how do we fix injection attacks? So implement input validation and use parameterized queries to prevent injection attacks. So that is the solution here. Lastly is broken access controls. So the APIs that don't properly enforce access controls can allow unauthorized users to access sensitive resources. So how do we fix this? So implement a strong access controls. And that's it. Also regularly audit your API. So log regularly to monitor uh, the potential vulnerabilities. So regularly audit your API and implement strong access controls. So by addressing these common authentication and authorization issues in API, you can significantly improve the security of your API and ensure that only authorized users can access its resources. So next is validation, input validation issues. So input validation is an important security measure that ensures the data received by an API is safe and secure. So input validation issues in API arise when an API doesn't adequately uh, validate the input data it receives from users. So this is a input issue. So these issues can lead to security vulnerabilities such as injection attacks, as I said earlier, cross-site scripting, also called as XSS. So also buffer overflows. So here are some input validation issues in API. So and also how to fix them. First one is, of course, insufficient input validation. So if your APIs that perform adequate input validation are vulnerable to injection attacks. So to fix this issue, implement input validation. That's it. To ensure that only valid data is accepted by the API. So what does this mean? So this includes the validating the data type, the format, the length, and the range. Next is to failure to sanitize user input. So APIs that don't sanitize user input can be vulnerable to cross-site scripting attacks or XSS. So how do we prevent this? So sanitize user. So what does sanitize mean? So it means to clean, or from to clean the code or the input that has been inputted by the user. So input the user input, sanitize the user input uh, for us to remove any potential malicious code or characters. You can search that all about sanitizing of user input, but we're not tackling that here today. Next is what we call buffer overflow. So what does this mean? So buffer overflow. So these are the APIs that don't properly handle input buffer sizes. So what this means is it can be vulnerable to buffer overflow attacks. So how do we fix this issue? So first, ensure that the input buffers are appropriately sized and that the API can handle large inputs without crashing or becoming unstable. So that is the solution here. So scale your API. Next is insufficient data encoding. This means is that APIs that don't properly encode input data can be vulnerable to injection attacks. So how do we fix this issue? Of course, ensure that the input data is properly encoded to prevent injection attacks. So lastly, failure to handle special characters. This is the most struggle we have as a developer, is that APIs don't properly handle special characters. Take note of that. By this, attackers can use this advantage. So how do we fix this issue? So implement input validation, of course. That checks for special characters and either removes them or properly encodes them. So that's it. So implement a input validation that checks special characters to remove them or to re-encode them. So to fix input validation issues in API, you should regularly audit your API for potential vulnerabilities and take appropriate measures to fix them. So these are some other input issues that you should prevent. You should not have this one. So you should prevent first. This is what we call cross-site scripting. I've said it already earlier, called XSS. So when does this occur? So this will occur when an attacker injects malicious code into an API request. So this which is then executed by the victim's web browser. So how do we prevent this? So of course, implement input validation. You should perform input validation. So it can be removed or encode potentially malicious characters. So there are many input validation tools that you can use in the internet. So search one of those. Next is SQL injection. So this is a type of injection attack where the attack injects malicious SQL commands to the API request. That it can result in unauthorized access to sensitive data, which means, in other terms, hacked. How do we prevent this? So again, input validation should be performed. Perform input validation rather to remove a I called earlier special characters. Bower overflow. I think this is a typo. I've already tackled this earlier. So next one is this one. Called DOS or denial of service. What does this mean? DOS occurs when an attacker sends a large number of requests to an API in a short period. Means, what a denial of service means, it can overload the server and prevent legitimate users from accessing the API. So how to prevent DOS or denial of service? So again, perform input validation. So we can detect and reject malformed or excessive requests. Next is improper format or data type. So this occurs when an API request contains data that is not in the expected format or data type. So you can, what this means is this can cause the API to fail or behave unpredictably. So how do we prevent this? Again, perform input validation. So that API can request that can contain valid data in the expected format. So additionally, API should follow industry standard security practices. So such as using secure communication protocols such as HTTP, use that. So implementing authentication and authorization and logging and monitoring. Logging and monitoring are one of the most simplest way to prevent this and to fix this validation input validation issues. Next one is encryption issues. This is the most crucial aspect of the API security because it protects sensitive data that is transmitted between the API and its client from interception and tampering, or what we commonly know as hacking. So encryption issues in API can occur when encryption is not properly implemented, configured, or maintained. So it leaves sensitive data vulnerable to attacks. So here are some common encryption issues in API and how to fix them. First one is weak encryption algorithms. What does this mean? So weak encryption algorithms are examples like outdated or broken encryption protocols like SSL. Those are old encryption protocols. Also, the early versions of TLS can be easily exploited by attackers. So use protocols such as HTTPS. So how do we fix this issue? So use a modern, a strong encryption algorithm. So aside from SSL, which is an outdated and broken encryption protocols, we should use TLS 1.3. That's a new version of the TLS. We can also use AES and SHA 256. Those are some examples of encryption protocols that are modern and strong. So also regularly update them to address any new vulnerabilities. So that is the fix here. Next is inadequate key management. So improper key management can lead to the compromise of encryption keys, which can allow attackers to decrypt sensitive data. So how do we fix this issue of inadequate key management? So API should implement strong key management practices, like let's see here, using secure key storage, regular key rotation, and key revocation procedures. Next is misconfigured SSL or TLS certificates. So this can cause encryption to fail, leaving sensitive data to expose. So how do we fix SSL and TLS certificates? So we should regularly check and validate those certificates. Ensure that they are properly configured and up to date. So that is the short answer here. Update the certificates. Next is insecure transport protocols. So insecure transport protocols such as HTTP can transmit sensitive data in plain text, make it vulnerable to interception and tampering. How do we fix this issue? So API should secure transport protocols like HTTPS to encrypt data in transit. So last one is improper data handling. So the examples of data proper handling are storing unencrypt data or failing to properly dispose of encryption keys that can expose sensitive data to attacks. What generally means encryption is to secure or to have a password with it. So that is I think the most logical term here. So how do we fix this issue? So we should implement a secure data handling practices. So such as encrypting data at rest, securely disposing of encryption keys, and using secure storage solutions. So by addressing these common encryption issues in APIs, you can significantly improve the security of your API and protect sensitive data from attacks. So it is important to regularly monitor and test your API's encryption mechanisms to ensure that they are working properly and to identify and address any new vulnerabilities that may arise. So next issue is what we call rate limiting issues. So what is rate limiting? So rate limiting is an important aspect of API security. So as it helps prevent abuse of API resources by limiting the number of requests that can be made by client to a given period. So rate limiting issues in APIs can occur when limits are not properly implemented or configured. So this can cause DOS, denial of service, talked earlier, DOS attacks, and other security threats. So these are common ones. So here are some rate limiting issues in API and how to fix them. First is insufficient rate limits. So insufficient rate limits can allow attackers to overwhelm an API with a large number of requests. So this leads to DOS attacks. So to fix this issue, we should implement appropriate rate limits. So based on the expected usage patterns and behavior of clients in order to prevent those security threats. So that is the fix here. Next is inadequate rate limit enforcement. So inadequate rate limit enforcement can allow clients to exceed their allotted rate limits, leading to DOS attacks and other security threats. So how do we fix this issue? API should enforce rate limits at the API gateway or proxy layer. Later on, we will talk all about API gateway to have more insight about this. And also, for to fix this issue, you should monitor and log all requests. That's it. So we can detect the prevent abusive behavior. Next is inconsistent rate limit configurations. So with this, to across different endpoints and APIs, this can lead to inconsistent and unpredictable behavior. That makes it difficult to manage and secure API resources. So how do we fix this? So the API should implement consistent rate limit configuration across all endpoints and APIs and should provide clear documentation and communication to clients about rate limits and usage policies. Like you can see in user term policy, you should implement those with your API. Next is rate limit bypasses. So this issue can allow attackers to evade rate limits and abuse API resources. So how do we fix this issue? You should implement additional security measures. So the common one is CAPTCHA. Yes, CAPTCHA. You can also use IP blocking or user agent validation. But the most common one here is you can use CAPTCHA challenges. So to prevent rate limit bypasses, because every time you refresh the API, it always asks for a challenge or a CAPTCHA challenge. So in order to not bypass the rate limit. So that's it. So last one is inappropriate response to rate limit violations. So an example of this is returning error messages or status codes that reveal sensitive information about the API or its clients that can expose to security threats. Now, how do we fix this issue? But most importantly, to prevent it. That is the most important logic here. So aside from that, you should implement the API some appropriate response codes and messages for rate limits. So you can use the status codes for the HTTP for rate limit violations that do not reveal sensitive information. So aside from showing the sensitive information through returning error messages or status codes, you can use the 404 error status code in order to not reveal the sensitive data in your API. So by addressing these common rate limiting issues in APIs, you can improve the security of your API and prevent abuse API resources by clients because they can sue you, remember. So it's important to regularly monitor and test your API's rate limiting mechanisms to ensure that they are working properly and to identify and addressing any new vulnerabilities that may arise. So there are also more common other API issues. Those were the main ones, but there are also other common API issues. So I've already mentioned earlier about cross-site scripting or XSS, but I will be having more of an insight about this. So these occur when when an untrusted not trusted data, untrusted data is included in an API request. It means it allows attackers to inject malicious codes or script. Now, how do we fix this? Use implement input validation or sanitization techniques. You can search yourself about that, but we can uh, really talk about here. But you can research, have research on them about sanitization techniques, but mainly about sanitization techniques. An example of this are whitelisting or blacklisting of inputs. It means to filter out that what uh, sanitization techniques are. Whitelisting and blacklisting means to whitelist to approve a input character or blacklist to exclude an input characters. So that is the fix here for XSS or other injection attacks. Next one is we called CSRF or cross-site request forgery. So this is an attack that occurs when an attacker tricks a user into making an unintended request to an API. So it fools the user. So how do we fix this issue? So API should implement CSRF protection measures. So what are those? So it requires a CSRF token in each API request and using HTTP only cookies. So the main fix here is to require a CSRF token in order to blacklist this input malicious code and also to use HTTP only cookies because they are secure. Next is broken authentication and session management. So this occurs when APIs do not properly manage users' authentication and session tokens. So it allows attackers to impersonate users. In order, it makes it allows the attackers to copy the user or steal sensitive information. Now, how do we fix this issue? So you should implement a strong authentication and session management mechanism. So an example of this are multi-factor authentication and token-based session management. Next is improper error handling. So this occurs when APIs return error message or status codes reveal sensitive information. So this is, I think I've already tackled earlier about improper error handling. So to recap again, to fix this issue, you should use appropriate error handling mechanisms like masking sensitive data, like blurring them out literally, masking the sensitive data in error messages, and standardized error codes so it will not clutter all over your prompts. Lastly is insecure direct object references. So this occurs when API is exposed to an internal object reference in an API request. So this allows to access unauthorized resources. So how do we fix this issue? So you should implement access control mechanisms. So example of this are role-based access control and object level permissions. So by addressing these common API issues, you can significantly improve the security and reliability of your API. It's important to regularly test and monitor your API. I can't stress this enough because for vulnerability and to stay up to date with the latest security for best practices and technologies to prevent new security threats. Now we're moving on all about what is API gateway. So in order to secure your API, you should use an API gateway. So what is an API gateway? It is a server. So a server that acts as a single entry point for client applications to access multiple backend services via APIs. So this it is responsible for routing incoming API requests to the appropriate backend service. So it handles authentication and authorization. It also enforce rate limiting and throttling and provide analytics and monitoring. Now, how to use an API gateway? So we should follow these steps. First is choose an API gateway provider. So there are many gateway providers available. So this means what server for the API gateway you will be using. So it can be both open source or commercial. So some popular options include AWS API gateway, Kong, uh, Kong, TIK, TYK, and API GEE. So those are some API gateway provider you can use. So next is to define your APIs. So define the APIs that your client application will use to access your backend services. So you should specify the API endpoints, your HTTP methods, and request/response formats. Next step is to configure your backend services. So configure your backend services to expose their APIs to the API gateway. So this typically involves setting up API endpoints and defining the request/response formats. Next is configure the API gateway. So through this, you can route incoming API requests to the appropriate backend service. So this involves setting up routing rules and configuring any necessary security, rate limiting, or throttling rules. Now, the last step is to test and deploy. So test your API gateway to ensure that it is correctly routing requests to your backend services and deploy it to your production environment. So once your API gateway is up and running, you can use it to manage and secure your APIs. So that is a short way of securing APIs is to use API gateways because it can simplify client access and improve performance and scalability. Finally, let's conclude. So we've covered a lot of grounds in this presentation about debugging and troubleshooting. So let's quickly summarize the key points we've discussed. First, we've talked about debugging and troubleshooting because that it is essential for ensuring the security and reliability for your API and maintaining a positive user experience. Also, we've tackled several strategies and techniques for debugging APIs, including logging, monitoring, and using debugging tools. We also talk about how to troubleshoot APIs effectively, that it is important to identify and isolate problems, analyze data, and to test and monitor APIs. We also tackled several common API issues such as authentication and authorization, input validation, encryption, and rate limiting issues, which can be addressed through best practices and proper implementation. We've also talked about best practices for API security, that includes implementing authentication and authorization, and what I've said earlier, API gateway. So overall, debugging and troubleshooting APIs is an ongoing process that requires continuous attention and monitoring. This doesn't happen over time to master it. So by implementing best practices and using the right strategies and techniques, you can ensure that the security and reliability of your API and provide a positive user experience for your customers. So, thank you for your attention, and I hope you found this presentation helpful. And God bless us all. Stay curious.